Welcome back, Cambridge class. Welcome to your third lesson on place value, and today we're going to look at comparing numbers. On the screen you can see two numbers that have been made on a place value chart. And Danny says A is bigger than B because A uses more counters. Now that is wrong, very, very wrong. To explain why Danny is wrong, we're going to work out what number is shown on each place value chart. So over here, we've got two tens of thousands, six thousands. I'm going to put a comma to separate the thousands from the rest. 300s, no tens, and 5 ones. Down here, I've got 3 tens of thousands, no thousands, no hundreds, no tens, and no ones. So Danny's saying this number is bigger than this number because it's used a lot more counters than this number has. But Danny is wrong because they've both got 5 digits, they've both got tens of thousands. This one's got 2 tens of thousands, but this number's got 3 tens of thousands, which is why 30,000 is bigger than 26,305. Let's have a look at another question. Okay, which number is bigger? 13,067 or 9,483? What you might want to do to work out the answer is draw yourself a place value chart and draw counters and see which number is bigger. Pause the video and have a go. Okay, I'm going to look now. So on this place value chart, I'm going to make 13,067. What I could do is start from the ones. So I've got 7 in the ones column. 1, 2, 3, 4, 5, 6, 7. I've got 6 in the tens column. I've got none in the hundreds column. I've got 3 in the thousands column. And I've got 1 in the 10,000s column. Over here I need 3 in my ones. I need 8 in my tens. I'm starting with my ones because it stops people from making mistakes by putting numbers in the wrong column. 1, 2, 3, 4, 5, 6, 7, 8, 4 in the hundreds, and 9 in the thousands. Five, 6, 7, 8, 9. Okay, so this just shows us really clearly that 13,067 is bigger because this number has got tens of thousands. It's got 1 tens of thousands number, but this hasn't got any in that column. So although the thousands number is bigger in terms of this column, this one is the smaller number because it doesn't have any tens of thousands. Rosie and Jack have each made a number. Rosie's number is at the top and Jack's number is at the bottom. Who has made the biggest number and how do you know? What I want you to do is write down on some paper how big Rosie's number is and how big Jack's number is, and then have a go at explaining which is the bigger number and how do you know. Pause the video now. Okay, so I'm going to write down what Rosie's number is worth. So Rosie has 8 tens of thousands, 2 thousands, I'm going to put a comma there, 4 hundreds, 2 tens, and 8 ones. And Jack has got 8 tens of thousands still, 5 thousands, 4 hundreds, 2 tens, and 8 ones. So So we've got 82,428 and 85,428. So because both numbers have got 5 digits, we'll look at the first digit first. They've both got 8 tens of thousands. So now move on to the second digit. This one's got 2,000, but this one's got 5,000, which means that 85,428 is the biggest number. And for an explanation, we could say 85,428 is the biggest number because although they both have 8 tens of thousands, Jack's number has got 5,000, which is bigger than 2,000. And it says, draw counters on a place value chart to show a number that is bigger than both Rosie's and Jack's. So what you need to do is draw yourself a place value chart that's got 5 columns, like this one. It's got 5 columns. Draw a number that's bigger than both Rosie's and Jack's. So because Jack's is the biggest number, I could have it in there and put some extra ones in as well. There's lots and lots of things that I could do. Okay, use 6 counters to make 5 different 5-digit numbers. I'm going to start you off by doing one possible option. So I've got 6 counters here. I need to make 5 different 5-digit numbers, and I've got 5 digits here. And this is my second attempt, this is my third attempt, this is my fourth attempt, and this is my 5th attempt. So what I could do is have my 6 counters all in the same box. What I could do is have 2 over here, 1 over there, 1 over there, 1 over there. So there's lots of different ways as long as you only use 6 counters and you make sure that your number has 5 digits. Pause the video and make 5 different numbers and then write down which is the smallest and which is the biggest. Okay, so another option, I could have 2 over here, 2 in here, 1 in there, and 1 in there. I could have, oops, one in each of these, and then 2 here. Something that I can't do is leave this blank, because if I leave this blank and just put the counters in the other 4 columns, then it only makes it a 4-digit number and not a 5-digit number, so I must have something in that one. Just check I've got that right. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so looking at my numbers that I've made, which is the biggest number? So my biggest number is going to be one of the numbers that's got 2 counters in its tens of thousands. So both of these have got 2 counters in the tens of thousands. So I've now got to look at the thousands column. This one's got 2 thousands, this one's only got 1,000, which means that this number here is the biggest number, which is 22,011. And which is the smallest number? I need to be looking at these 3 numbers. These have all got 1 tens of thousands in them. We need to move on to the next column. This has got 1,000, this has got 1,000, but this has got no thousands, which means that this one is the smallest number. It's 1,014. Sorry, it's not. It's 10,014. Okay, moving on. Circle the greatest number in each pair. So I've got 10,000 or 1,000. Now what I could do is write them all in this column here. So I've got 10,000. I'm going to start over here. 0, 0, 0, 0, 1. So that's my 10,000. My 1,000 would look like this. Okay, which is the biggest number? Well, 10,000 is the biggest number because that one has a digit in the 10,000s column, whereas 1,000 doesn't. It only has one in the thousands, hundreds, tens and ones. B, 2,300 or 3,200. They've both got 4 digits, so I can look at the first digit. This has got 2,000s, this has got 3,000s, which means this one is bigger. Now I've got 34,975, 9,345. So these have got ones, tens, hundreds, thousands. This has got ones, tens, hundreds, thousands, tens of thousands. So this is bigger. 5,400, 4,500. They've both got 4 digits, so we need to look at the first one and compare them. This one's got 5,000s, this one's only got 4,000s, so this one is the biggest. Now I've got 56,000 and 6,500. This has got 4 digits, this has got 5 digits, so this one is going to be the biggest. And this one is 9,999, this one is 99,999. This one's got 5 digits, it's got tens of thousands as well. This one's only got thousands. Okay, now have a go at comparing these. If you find it useful, draw yourself a place value chart like this. You could write them both in and then compare which is the biggest and which is the smallest. And this time you need to write down which is the smallest number. Pause the video now. Okay, let's see if you're right. So this one is 15,200 and this one is 10,000. They've both got 5 digits, so I can look at the first digit. This is a 1 tens of thousands. This is 1 tens of thousands. So I need to move on to my second digit. This is 5,000s and this is no thousands. So this is smaller. Now I've got 174,000 and 300,000. They've both got 6 digits, so I can look at the first digit. This has got 100,000s, and this has got 300,000s. So this one is the smallest. Okay, I've got 2 numbers again that have got the same number of digits. They've both got 5 digits. This has got 5 tens of thousands. This one's only got 4 tens of thousands. So this one is the smallest. Now I've got 80,000 and 8,000. This has got 8,000s. This has got no thousands but 8 tens of thousands. So this is way bigger. It's 10 times bigger. So I'm going to circle this one. And then here we've got 365,008 and this is a million. Now the other day I told you that a million had 7 digits. This one's only got 6 digits, which means that 365,008 is the smaller number. Okay, let's try these together. Remember that the crocodile eats the biggest number. So if you have your symbol like this, the crocodile would be eating whatever was on this side. The biggest one would be on this side. And if your symbol was like this, the crocodile, the mouth, would be eating whatever was on this side, the biggest number. So write one of those symbols to compare the pairs of numbers. Which is the biggest number? Well, that's got 3,000s and that's got 3,000s. That's got 500s and that's got 400s. So this is the biggest number. The crocodile wants to eat that number, so the mouth needs to be open on that number. B. 5,400, 4,500. They've both got 4 digits. This one's got 5,000s. This one's only got 4,000, so the crocodile eats the biggest number. 62,500, 65,200. They've both got 5 digits. Look at the first one. It's got 6 tens of thousands, 6 tens of thousands. Let's move on to the second digit, 2,000. That's got 5,000. This is bigger. So crocodile's going to eat that one. 147,500, 145,700. They've both got 6 digits. They've both got 100,000. They've got 4 tens of thousands. This one's got 7,000. This one's got 5,000. So 7,000 is the biggest. Now you try these. Pause the video and have a go. Let's go over the answers. 909 is bigger than 908. 81,227 is bigger. 7,262 is bigger. Now this is, what I'm going to do is write the answers down to help me remember. 983. 983. So that's equal. They are the same. 200 is bigger than 29. That's got 3 digits, that's got 2 digits. I'm going to write down the answers again. 300 add 27 is 327. 200 add 100 is 300. Add the 27 is 327. So they are also the same. I've got 4,000 plus 10,000, so that's 14,000. And 13,000, so 14,000 is the bigger number. Here I've got 19,000, add 200, add 70. So 19,270. And that's 19,270, so they are equal. Okay, here I've thrown in some Roman numerals to see if you can remember how to do them from Miss Hawk's lessons last time. So, what I suggest you do is on some paper, write down what XXVII represents and what 10, 10, 1, 1, 1, 1, 1 is, and then write your symbol. And the same for this one. Pause the video and have a go. Okay, so I know that XX is 20 and VII is 7, so that's 27. Here I've got 20, 1, 2, 3, 4, 5, 25. So 27 is bigger, the crocodile eats the bigger number. And down here I've got 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And here I've got XCI. XC is 10 before 100, so that's 90. And then add the 1, 91. So 91 is bigger than 19, so it goes that way round. The crocodile eats 91. Okay, which is the greatest number in each list? And which column did we look at and why? Let's do the first one together. Well, they've all got 5 digits in the number. And they've all got a 1 at the beginning. So I'm going to look at this column. This is the thousands column. This has got 6,000, 9,000, 8,000, 3,000. So 9,000 is bigger. I'm going to circle this one. This is the greatest number. Pause the video and have a go at the next two. Okay, you should have noticed that they all have 1 tens of thousands, they all have 7,000s, and they all have no hundreds. But the tens number is different in some cases. So it's got 9 tens, 4 tens, 8 tens, 9 tens. So I'm going to have to compare this one and this one. If the 1709 are all the same, 1709, we've got to move on to the next column. This has got 6 ones, this has got 9 ones, which means this one's the biggest. So here we had to look at the thousands column. Here we've had to look at the tens column, but then the ones column. Which number is bigger here? Well, they've all got 5 digits, but they've all got a different number of tens of thousands. This has got 2 tens of thousands, 3 tens of thousands, 4 tens of thousands, 1 tens of thousands. This one's bigger, so we've had to look at the tens of thousands column. Okay, have a look at this challenge. Whitney is sorting some numbers. She puts the numbers into a sorting diagram. This is called a Venn diagram. In this whole circle here, we need to have numbers that are less than 70,000, which it tells you here. In this whole circle, we're going to have numbers that are bigger, greater than 120,000. Anything in this middle section, the intersection, needs to be numbers that are less than 70,000 and bigger than 120,000. The first one has been done for you. So 145,000 is bigger than 120,000. So it goes into this circle. But is it less than 70,000? No. So it goes in this part of the circle, but not in the middle, in the intersection. So we've done this one. Can you draw yourself 2 circles and write the other numbers in the right place on the Venn diagram? And pause the video while you do this. Okay, so this one, 300,000. I'm just going to write it down in digits. That's what that looks like, 300,000. And that is bigger than 120,000, but it's not less than 70,000. So that's going to go in this section. I've done that one. 799. Is it bigger than 120,000? No. Is it less than 70,000? Yes. So it goes in there. 85,400. Is it bigger than 120,000? No, it's not, is it? Is it less than 70,000? No, it isn't. It's bigger than 70,000, but it's not bigger than 120,000. So where does it go? That one needs to go on the outside because it doesn't qualify for any of those statements. 62,000. It's less than 70,000. So that needs to go in here. And 620,000 is bigger than 120,000, so that goes in here. Have you noticed that we don't have any numbers in the intersection? Why is that? That's because a number can't be less than 70,000 and bigger than 120,000 at the same time, so that's empty. But any numbers that don't match any of those requirements need to go on the outside. Okay, write all the possible digits that could make each statement correct. So this means the crocodile is the biggest number, so the open mouth is on this side. This has got to be bigger than this one. If you've got 9,700 there, what has got to be in this box to make it correct? There might be more than one possible answer, and it says write all the possible digits that could make each statement correct. If I have a 7 there, is that bigger than this one? Yes. If I have an 8 there, it's going to be bigger. If I have a 9 there, it's going to be bigger. So I could have 7, 8, or 9 to make it correct. This means this number's got to be bigger than this one, and this means this one's got to be bigger than this one. See if you can write down all the possible digits that could make each statement correct. Pause the video while you do this. Okay, this time if I write a 7 there again, does that mean this is bigger than this one? 9,700, that's got 1 10 and that's got 5 tens. So this would make it smaller, so I can't have a 7 there, but I could have an 8 there, or I could have a 9 there. So my possible options here are 8 or 9. And here it's got 9 7, but that's a 5. So it's got to be bigger than 51 at the end. So I could have 56, I could have 66, 76, 86 or 96. So I could have 5, 6, 7, 8 or a 9 in there, and the second number would be bigger than the first number. Okay, this is the last question of the day. Which digits can replace the missing digit? We've got 275,118. It's got to be bigger than 270 something thousand and 24. See if you can have a go. Pause the video. Okay, so let's just have a look. If I put a 5 there, does that make this number bigger than this number? 275,118. 275,024. Yes, it does, doesn't it? So I could have a 5 there, because this is now smaller than this number. Could I have a 6 there? If I have a 6 here, does that make it smaller or bigger than this number? I'd have 276,000. So it's going to make it bigger, so it's not going to work. I need to have a smaller number over this side. Could I have a 4 here? Is 274,024 smaller than 275,118? Yes. So this time I can have a 5, a 4, a 3, a 2, a 1 or a 0. The last question, the same digit is missing in each number. So this number, this is a missing digit here, the same number needs to go in each position. So if I think that a 1 would work there, a 1 has to work there, and a 1 has to work there. This means 600,000 and something is smaller than this number, which is smaller than this number. This is the biggest, this is the second biggest, and this is the third biggest. What could the missing digit be? And have a look and see if there's only one possible option or if there's more than one option. Pause the video while you have a go. Okay, I know this can't be a 1, because if I have a 1 there, that's not going to work. This number is not going to be bigger than this number, so I can't have a 1. If I put a 6 there, and a 6 there, does that work? 679,466 is bigger than 600,006. Yes, that would work. Could I have a 6 here then? 961,255. Yes, that's definitely bigger. So I could have a 6. Could I only have a 6? Would it work if I had a 7? If I had a 7 there, 779,466, is that bigger than 600,007? Yes. And then 971,255. Could I have an 8 here? $600,008. 879,466 is bigger than 600,008, 981,255 is bigger than this number. Yes, so far I can have 6, a 7 or an 8. Would a 9 work? So 991,255 is bigger than 979,466, which is bigger than 600,009. That works as well, doesn't it? So the possible options are 6, 7, 8 or 9. Well done today. We'll see you tomorrow for some more place value.